Hi everybody, my name is April, and today I'm going to be talking about the unit circle and the trigonometric functions associated with the unit circle. So here on the left, I have written down some key concepts to remember when thinking about the unit circle. So in this circle, the radius is 1, and the radius for any given triangle on this circle is the hypotenuse of that triangle. This makes it easy to calculate the sine and cosine because the sine is, let's look at this orange triangle here. The sine is going to be the y value, because it's the opposite from the angle, over the hypotenuse. And since the hypotenuse is the radius, which equals 1, we can just say that the sine of the angle is going to be equal to the y value of the coordinate. Now the cosine is going to be adjacent because we always reference the angle from the x-axis. So the cosine is adjacent over hypotenuse. So we can say that the cosine is the x-coordinate of any given point on the circle. And then the tangent is just going to be y over x because it's opposite over adjacent. Now, given that sine of the angle is going to be y, cosine is going to be x, and tangent is going to be y over x, we can also say that the cosecant is going to be 1 over y, secant is going to be 1 over x, and cotangent will be x over y. Now, if we begin our circle right here on the x positive axis, we will start it at 1, 0. So we can say that cosine of 0 degrees or 360 degrees is going to be 1, and the sine will be 0. 360 degrees is also going to equal 2 pi if we're speaking in radians. Now, we're moving in a counterclockwise motion when we're going along the circle. So here I have 3 points. This one is at the 30-degree angle. The second one is going to be a 45-degree angle. And this third one will be a 60-degree angle. And those are the most important ones to remember because the other 3 quadrants are going to have the same values, and the only reason they will change is going to be based upon the quadrant that it falls in. It's going to change, whether it's positive or negative value. Now, over here on the right side of the page, I have the 3 different triangles that we will be referencing. The 45-degree right triangle, the 60-degree right triangle, and the 30-degree right triangle. Now, the 30, 60, 90 triangles are essentially the same triangle. However, we'll be focusing on the 2 different angles that are associated with them, so the 30 degrees and the 60 degrees. Here I have written down the 45-degree triangle is always going to be associated with a pi over 4 value in radians, and the 60-degree will always be associated with the pi over 3 values. The 30 degrees will always be associated with the pi over 6 radian. Now we can look at some things that the trigonometric functions have in common with each other that can help us quickly recall the values for any given angle of 30, 60, or 45 degrees. So any sine or cosine of those 3 angles will have a denominator of 2. So I've left blank all of these so that we can fill them in as we go. So first we can go ahead and fill in the denominators, which is going to be 2. So we'll put a 2 here, here, and we'll just go around and fill them all in. Okay, easy enough. Now we need to figure out what the numerator will be. So one thing to remember is the numerator for any of these sine or cosine angles of 45, 30, or 60 degrees will either be the square root of 1, 2, or 3. Now, the square root of 1 is 1, So we don't actually have to write the square root sign for that. Now, if you start here and you move along the circle, you can see that the x starts at 1 and it's going to be decreasing as we move along the circle. Okay, so all the way up until the 180 degree or pi value, which is -1, 0. So we're going to take the biggest number of the 1, 2, 3, and we're going to start on the right. And for the x value, we're going to write 3, 2, 1. And then on this side of the y, we're going to start with the 1, because this is going to be negative. So it's going to go 1, 2, 3, but we're going to change the value to a negative value, and so it is still decreasing. So we'll go 1, 2, 3. And then we can go ahead and put our square root over that 3, over the 2, and then come over here, add that square root. And then we're going to want to change, because we're in the second quadrant, we know it's going to be a negative x value. So we're going to throw a negative sign in there, and over here, and over here. Now for the y values, you can see as we move up the circle and around, the y values will be increasing. So we're going to start with the 1 on this rightmost point here, and we're going to do 1, 2, 3. And then we're going to add our square roots. And then over here, we're going to go 3, 2, 1, because as we come around on this side, we're actually decreasing. So we'll start with the largest value up top and just move down. And then make sure you add your square roots. Now for this lower portion of the circle, you can see that the x value will be increasing all the way up to that point. So we're going to start with our 3, 2, 1, because this side will also be negative. So -3, negative square root of 3, sorry, let's add our square roots, is going to be more negative than negative square root of 2 or -1. And for the y value here, this is a negative quadrant here. This is all negative on this side here for the y values. So we're going to do 1, 2, 3, because it is becoming more negative as we move down and around the circle. So we'll add our square roots and our negatives because we are in the third quadrant. Both values of x or y or sine or cosine will be negative. Add your square root here and a negative. And then over here, you just add a 3. You're going to basically do the opposite of what you just did. 1, 2, 3, 3, 2, 1. And like I said before, you got to add your square roots. And we are in the fourth quadrant, so we know that the y value will be negative. Now, one thing to make note of for the 45-degree angles, the sine and cosine will have the same value of square root of 2 over 2. It will be paired together. It just depends on which quadrant you're in as to whether or not it will be positive or negative value. But it's pretty easy to remember because it's the same value that you are pairing it with itself. And then for the 60 and 30 degrees, we're always going to have the square root of 3 over 2, and the 1/2 will always be paired because, like I said before, this is essentially the same triangle. We're just focusing on the opposite angles of 30 and 60 degrees. So basically, whenever I am trying to recall these values of the sine, cosine of these three triangles, I really just try to visualize where on this circle would that triangle fall. So here I have the green outlined with any of the 45-degree triangles, which are also the pi over 4 values. And I know that those are all going to be square root of 2 over 2. And it just depends on where it falls, which quadrant it falls into. So let's take this 3 pi over 4 value. That's going to be equal to 135 degrees, which is essentially 90 degrees plus 45. So we know, because it is past 90 degrees, but before 180, it's going to be in the second quadrant, which is going to give us a negative value for x, or cosine, but a positive value for the sine, which is y. Now, another reason it helps me to really visualize these reference triangles is the fact that here on this 30, 60, 90 degree triangle, when we're focusing on the 60 degrees, you can see that this side, which is going to be in reference to the x-axis here, or the cosine, you can see that it is shorter than the opposite side, which is the sine value. So you can basically figure out that the cosine value for the 60 degrees is going to be the 1/2 value for cosine. And then the sine would be the square root of 3 over 2, because it is a larger number. So you can actually visualize that. And for this 45-degree right triangle, 45 degrees, it's going to be on both of those angles is 45 degrees. So we know that both of these sides are going to be equal in value. Now let's focus on the third trigonometric function that I just touched on, which is tangent, which is going to be opposite over adjacent, which is y over x. Now we can easily figure these out if you can recall the sine and cosine values of these three triangles. It's just simple math that we're doing at that point. Now let's look at the tangent value for the 45-degree angle, or the pi over 4 values. Let's do 5 pi over 4. So that is going to be 225 degrees, and we know that this is going to fall between pi and 3 pi over 2. So we know we're in the third quadrant. So we're going to have two negative values with the x and y. And for the 45-degree angles, we will recall that they are the same value, square root of 2 over 2. So when you are dividing the same value by itself, you're going to be given 1. And because we have two negatives, we're going to have a positive 1. Now let's take a look at the other three trigonometric functions, which I mentioned earlier, but we haven't really gone into yet. And those are the cosecant, the secant, and the cotangent. Now these values are going to just be the reciprocal of the other three functions. So the cosecant is the reciprocal of the sine, the secant is reciprocal of the cosine, and the cotangent is reciprocal of the tangent. Now let's talk for a minute about the four values that fall directly on the x or y axis. So at 0 or 360 degrees, or 2 pi, 90 degrees, or pi over 2, 180 degrees, or pi, and 270, or 3 pi over 2. Now those values, we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So when we're figuring out the secant or the cosecant, or even the tangent or cotangent, some of these values will be undefined because of the zeros that we have here. So let's look at the 270 degree 3 pi over 2 value, which gives us the cosine of 0 and the sine as negative 1. And let's look at cosecant. Cosecant is going to be the reciprocal of sine, which is negative 1. Now if we take the reciprocal of negative 1, we're given negative 1. So the cosecant is going to be the same as the sine value, negative 1. However, the secant is going to be 1 over x. 1 over 0 is undefined. So for anything that is on the y-axis, we have the x or cosine as 0. So we know that our secant, if it falls on that y-axis, the secant will be undefined. And if we look at the x-axis here, those 2 points, we're given the 0 for the sine value. So we know that the reciprocal of the sine value, which is cosecant, will also be undefined. And then if we look at tangent, is going to be y over x. So wherever the x is 0, so on the y-axis here at 90 degrees and 270 degrees, the tangent will be undefined, while the cotangent will be defined because we have x over y, which is 0 over negative 1, or 0 over 1 up here. So the cotangent of these are going to be 0. And just like the y-axis over here on the x-axis, one will be defined and one will be undefined. So because the y value is 0 in this case, the cotangent will be undefined and the tangent will be equal to 0. Well, I think that's all I have for you today. I hope this was helpful, and I hope you are able to remember these trig functions and can just easily think of the unit circle and envision those triangles that you're making with any of the given angles. Thank you for your time.